Yes, good afternoon, everybody. So I'm a professor of natural language processing at the engineering school in Yverdon. It's not so far from here, and it's part of the University of Applied Sciences of Western Switzerland. That's in French, HESSO. I wanted to make a brief presentation with just one idea. We are developing a chatbot platform, which we call Placat. It's subsidized by HESSO. And we have a number of problems related to how to train this chatbot to make it robust. And I will give you an idea about our solution. So at the beginning, we started with some observations of the landscape of chatbots. And we found that indeed there are quite a number of conversational agents out there which are able to answer questions. You're no doubt familiar with some of them, like Siri or Echo. Actually, they know quite a lot of things. We refer to them as Little Miss Brainy. And we also find out that when people push them a bit off limits, when they try to just chat, they actually stop quite quickly when pushed out of domain. But you're maybe also aware of the fact that using a lot of machine learning, people have also trained chatterbox, so chatterbots, let's say. They're often trained on movie dialogues, and they're able to carry on conversations for quite some time. Often they are considered to be merely entertaining. You can maybe use them to, I don't know, exercise in English or something like that. But it is very difficult to plug into them some knowledge from a different database. So we wondered, how is it possible to get the best of both worlds? So to provide access to knowledge, but from a robust chatbot. So our Placat project, to which we referred a bit unshamedly as Mr. Clever, relies on a simple strategy. We train and implement actually two different chatbots. And in the middle, our front end dispatches utterances from the user to either of these chatbots. And this is done according to what we can call the dialogue acts. You can think simply as, is this utterance from the user a request from information, in which case we push it towards Little Miss Brainy, or do we categorize it as simple chat, the user pushing a bit the chatbot off limits, and then we move this to our robust chatbot trained on movie dialogues. So this is only a spotlight. I'm not going to give so many details. In fact, all of the components are based on state-of-the-art technology, which is quite actually simple to re-implement. It's not always very easy to retrain so that we achieve the interesting results that we want to get. On the question answering part, so Little Miss Brainy on your left, we actually use a question answering system. Probably know that there is a lot of advertisement around BERT. BERT is excellent at answering questions. In fact, it is on condition that you give it the right paragraph. And that is how the squad dataset actually tests the accuracy of BERT on question answering. So in our case, the challenge is a bit different. We don't have the right paragraph, obviously. So we play with Wikipedia and we combine a paragraph retrieval module and then the BERT-based answer extraction module. So this already shows that it's not just a matter of having a lot of data and using machine learning. The paragraph retrieval component is not a very trainable one. It is actually based on traditional information retrieval techniques. And then indeed, our Mr. Chatterbox on the right side is simply a recursive neural network trained on a lot of movie dialogues. And here the challenge, again, the theory is quite simple. You just take the data, train, and get the result. You realize that politeness is maybe not the first quality that you can see in this agent. So movie dialogues are not really great for that. So you have to clean a bit the data so that you achieve a socially acceptable behavior on this side. On the dialogue act part, Again, there is extensive literature on it. We just use a bag of words classification. We decide, is this a question or is this basically just chat? So here actually the training is quite simple. We actually take half of the data from our chat data, movie dialogues. Half of the data are squad questions. Then we put them together. It's labeled by construction. So that is how we train our dispatcher, which is in the middle. For the moment, we distinguish only these green and blue cases. But the idea is to refine the classification model and be able to treat slightly more subtle dialogue acts, like obviously greeting versus chit-chat, or new question versus follow-up question. Now, given that I got 3 more minutes since Saturday, I can say that on the front of the follow-up questions, we actually have been quite successful in using a pronoun detection system, recognition system, which is something which is very handy in dialogue. So people often ask several related questions about the same entity, and obviously they don't repeat the name. So it turns out that it's quite feasible to use the model from Hugging Face to solve those pronouns and to actually be able to detect the coherence between the questions and respond appropriately. So no demo here, but actually it's a very small snapshot from the text-based development interface. One of our technical challenges for us engineers was that we want to make it functional as an app on Google Home, which it is actually now. So this comes with some advantages, some developer tools from Google, and it works so both in text mode and in speech recognition mode. But our goal is also to push it towards some real-world situations. For now, we answer quite a lot of questions from Wikipedia. That's very general, but it's not necessarily a business case. So we are exploring the possibility to actually team up with a company and focus the document set so that the knowledge base is actually more focused and the questions are addressed properly on this base. So if you have any ideas, I would be very glad to hear from you at the coffee break. Thank you very much.